All right, let's get started on today's notes, which is arc, length, and area of sectors. So before we start this lesson, you will need a calculator. So please pause the video and grab your calculator so that you can type in all the calculations that I'm typing in just to make sure you get the same answer. So we have two goals for today. I can find the length of an arc in a circle, not the measure, that's what we've already done, but the length. I can find the area of a sector. So I can find the area of a sector. So let's first explore that topic of what's the difference between arc measure, which we already know how to do, and arc length. So the measure of an arc is given in degrees, and sometimes it's in radians, but not in this class, and refers to how much of the 360 degrees has been passed through. So, for example, this blue arc right here, let me get my highlighter out so I can highlight it in blue also. This blue arc right here is 80 degrees. It's created by the central angle, it's 80 degrees, and it's 80 degrees of the 360 degrees there are total. So it says next, well, what is arc length then? Because that's the arc measure. Arc length is a portion of the circumference of a circle. So I'm going to write that down. Arc length is a portion of the circumference of the circle. So, circumference, let's make sure we know what that means. Circumference is another word for perimeter. It is only used on circles. So instead of saying the perimeter of the circle, which this would be that, we call it circumference instead. So it's just how long is this one piece here, okay? So, and the way I like to think of it is that if I took this blue piece and I straightened it out and busted out a ruler, how long would it be? That's what we're finding, the actual length of it. So here is the arc length formula. Before we start the arc length formula, you have to know the formula for circumference of a circle. So circumference of a circle is the formula capital C equals 2 times pi times radius. So 2 times pi times radius would give me this whole entire length right here. But we're only doing part. So we are going to now get our arc length formula. So it's just a portion of this. We use capital L equals. You're going to use the circumference formula, 2 pi r, but you're only going to take a portion of that. You're going to take m degrees of the 360 degrees. Realize this is going to take a percentage of that, and that's what we're doing here. All right, so you do need to know the formula. The formula will not be given to you, but if you memorize the circumference formula, then it's not hard to add on that you need m of the 360 degrees. Okay, here are some examples. Given the circle, find the measure and length of each arc. If necessary, round to the nearest thousandth. So we'll start with the arc measure. So first, let's go over to the circle, and I'm going to fill in any missing angles that I know. Realize the arcs are the same length, but I'm not going to fill in those too. So what I mean by that is I'm not going to put 50 here too. Like I can clearly understand that that's 50. So go ahead and on your sheet fill in this missing angle and this missing angle real quick. Okay, so if you did that, you should see that we have diameters in the circle. So this is a straight line right here. So this is 180 degrees. So that first missing angle right here is 60 degrees. Same thing here. Here's another straight line. This is 180 degrees. So 180 minus 50, and we have this is 130 degrees. Other things that you should notice is that the radius is 6 centimeters, and that's labeled on the diagram. Okay, so let's get our first arc. Our first arc is arc AB. I'll use the highlighter for these, so I'll highlight that in orange. Arc AB. All right, so first off, I want to know its measure. Measure we already learned. It's the same as the measure of the central angle, so 120 degrees. Now I need its length. So I'm going to put the formula off to the side and put the answer on the answer line. So length is equal to, you do 2 times pi times the radius. The radius in this case is 6. We already saw that right here. Times, and now I need the measure of the arc, which is 120 degrees, over 360. So you're taking 120 of the 360 degrees available. So now what you're going to do is you're going to type this in your calculator to get your answer. You are going to get a decimal and you're going to round it to the nearest thousandth. So in my calculator, I'm going to hit 2 pi. You don't have to hit the time sign, it's implied. Parentheses, 6, close the parentheses. Open a new parentheses, 120 divided by 360, close the parentheses. If you type it that way, you should get the right answer. Now your calculator does have to be in degrees since it's 120 degrees. So for some reason, if you've moved your calculator into radian mode in the past few weeks, please make sure you move it back to degree mode. If you're not sure how to do that, just send me either an email or a remind message and I can walk you through it via video chatting or just through an email. Okay, so you should get 12.566, and then I need a unit on this. This is a length, so it's how long it is, and the unit is centimeters, so centimeters. All right, pause the video and go ahead and try BC on your own real quick. All right, if you did it correctly, you should have the measure of BC, which I'll highlight here in red. This is BC right here. That is 60 degrees. And then doing 2 times pi times 60, times 6, times 6 times 60 over 360. You should get the answer of 6.283 centimeters. All right, we'll do C together, and you can pause the video and try CAD on your own. So let me get a new color here. So arc ABD. Realize if I'm starting at A and I have to get to D and go through B, ABD, this arc right here. So first off, I need to know the measure of that arc. I can either add 120, 60, plus 50, or I can do 360 minus 130 because that's what's left over. Either way, you should get that that arc is 230 degrees. Plug it into your formula. 2 times pi times 6 times 230 over 360. Plug that into your calculator, and you should get 24.086 centimeters. Go ahead and pause the video and try ArcCAD. All right, if you did it, you should have ArcCAD. We have to make sure we know what ArcCAD is. C, I can't go this way because I'm going through D, right? So I want to go from C to D. So if you're having problems with it, put like a dot on C, put a dot on D, the ends, and just say I have to go through A to get there. So here's CAD. That is 310 degrees. Ooh, that doesn't say 310. 310 degrees. 2 times pi times 6 times 310 divided by 360 is 32.463 centimeters. So that's how you find arc length. So you just have to make sure that you're reading. If it says find the arc measure, what we've been doing, right? Just how many degrees is it? If it says length, you're using the arc length formula. All right, next we have to talk about area of a sector. So area would be like a piece of the pie, all right? So here in the blue, that is a sector. The whole circle, this whole circle right here, if I wanted to find the area of that whole circle, area of a circle is pi r squared. These formulas should sound familiar because it's not the first time you should be hearing it. Now, if I just want a portion, so once again, this would be m degrees. So that arc would be m degrees because it's a central angle. If I wanted the area of that sector, if you had to guess that formula, I bet you'd guess it right. its area is equal to the area formula, pi r squared. But I don't want the whole circle, I just want part of it. I want the m degrees out of the 360 degrees. Okay, so we're going to find the area of the sector shown. So I'm also going to show you how to find an exact answer versus a rounded answer in this section. You can do this with circumference also. You can find an exact answer for circumference, and we'll cross that bridge when we get to it. Okay, so first off, let's write down the formula here. So I need area of a sector. So I go area equals pi times, I need the radius squared, times the measure of the arc over 360. So if you wanted to, you could do the skeleton here. Radius is 6, m is 72 degrees. All right, so to get the exact answer, what's going to give me a answer that I have to round is putting pi in my calculator. So I want to refrain from putting pi in my calculator. I want to put everything else except pi and then keep pi in my answer. So I'm going to do 6 squared, parentheses, 72 divided by 360, close the parentheses, and then hit enter. So my exact answer is, you should still sometimes get a decimal. In this case, you will. You get 7.2, but realize we didn't put pi in the calculator, so it's still times pi, 7.2 pi, and then area is always in units squared, so this is centimeters squared. Now, if I want the answer round to the nearest thousandth, I can retype this whole entire thing in my calculator, or I can just type 7.2 pi in my calculator. Go try both. See if you can get the right answer either way. This is obviously going to be a shortcut way, so I would do that. All right, my exact answer, 22.619, and then don't forget your unit. This is area, so centimeters squared. All right, go ahead and try the next one on your own. Try to get the exact answer and the rounded answer. Pause the video and try it. Okay, so you should get area equals pi times the radius of the circle, which is 6. It's not always 6. I feel like it's been 6 a bunch of times now. Times 90 over 360. Once again, to get the exact answer in my calculator, I'm doing 6 squared, parentheses 90 divided by 360, close the parentheses, enter. That will give me 9. So my exact answer is 9 pi centimeters. Nope, those are feet. Should go back and fix that. Feet squared. Put 9 pi in my calculator to see what the rounded answer is. 28.274 feet squared. Make sure you're using the pi button and not typing 3.14. That's a rounded answer, and we know we don't use rounded answers. Okay, the rest of this is practice, so I'm just going to say go ahead and try it on your own real quickly. If you feel like you're good to go, then you can go ahead and stop notes and start working on the homework. If you feel like you still need help, I would pay attention because this is how the problems on your test are worded. So it says, given the circle to the right, find all the requested information. So first off, I need the measure of arc AB. Here's arc AB. That's 112 degrees, just like the central angle. They also want me to find the measure of the arc ADB. ADB. So this arc right here. This arc is not labeled, but it's the same as this angle right here. And I can easily figure out that angle by doing 360 minus 112. If I do 360 minus 112, I know that this angle is 248. That's a 4. So this arc's 248. This arc is 112. So 248. All right, so it says find the length of AB, this arc right here. So I'm going to use my length formula. L equals 2 times pi times the radius, 7. See, I told you it changed. Times 112 over 360. Round your answer to the nearest thousandth in the directions. Pop that in your calculator. 13.683 feet. Do the same thing for the next one. L equals 2 times pi times 7 times 248 over 360. And you get this length is 30.299 feet. Once again, you can always pause the video and try typing in your calculator yourself to make sure that you're getting the same answer. I'm going to box these also since they are my final answers. Oops, I forgot degrees on that one. All right, area of the shaded sector. So this right here is the shaded sector. So I'm going to use my area formula. Area equals pi times radius squared times measure of the arc, 112, divided by 360 degrees. Pop that into my calculator. Notice it's saying I want all of my answers round to the nearest thousand, so I don't have to get an exact answer. So if I don't have to get an exact answer, I'm typing pi 7 squared parentheses 112 divided by 360 close the parentheses. So if you don't need an exact answer, throw the whole thing in your calculator. You get area is 47.892 feet squared. Area of the non-shaded sector, area equals pi times 7 squared times, that was 248 degrees over the 360 degrees. Area equals, pop the whole thing into your calculator, and you get 106.046 feet squared. All right, the very last one, it says, consider the circle shown. How much longer is AB compared to AB? For right now, we're not going to worry about this. This is more of like getting your brain thinking and going through it as you're working on your own. I don't want to make anyone think that this is actually harder than it is, because it's pretty simple as long as you know the formulas. So that's it for today. You can go ahead and rate yourself on how you feel about these two. You can do that out loud or in your head. But do you know the formula? Length equals 2 pi r times measure of the arc divided by 360. If you do, you should be good. Do you know the formula for area of a sector? Pi r squared times measure of the arc over 360. If you do, you should be good. All right, that's it for today. Go ahead and work on the homework, which is 9 homework